Hello, everyone. Good morning. I hope you're excited for session 2 of Introduction to D3. Again, my name is Paul Buffa. I'm the head of product education at Observable. and I'm really excited to walk you through today a lot more D3 concepts. So why don't we jump right in? So, same as yesterday, I've got a few team members here with me today. So, I have Allison and Wayne who will be helping out TA the course. So, if you ask questions in the chat, they'll be there to help you. So, feel free again to ask any questions. And we also have that community Slack channel if you've got more longer form questions you need some help with. So, we did a whole lot yesterday. I'm guessing many of you saw yesterday's session and are here again today for more D3. So yesterday we did kind of a rapid walkthrough of lots of concepts, lots of frameworks and languages that are all part of working in D3. So it could have been a little fast yesterday, and today we're going to slow down a bit, right? We're going to go more into D3, more into how to build visualization, and not have to cover so many high-level topics. So hopefully today you'll find the pace a little bit better than yesterday. So we've got a bunch of different things we're going to cover today. We're going to talk about scatter plots. What makes a scatter plot and how we can make our own scatter plot in D3. And part of that, we're going to be going through scales, a little bit more into the canvas, so how, the medium in which we make our visualization, data joins for actually creating our scatter plot, and then we're going to go through an entire scatter plot example. So we're going to build it from scratch together. So as the same as yesterday, I'll keep an eye on the chat here if there's any questions as well. So just taking a quick look. Looks like everything is going smoothly. So why don't we jump right into what makes a scatter plot? So as we mentioned yesterday, when we're working with D3, we have to build everything in our visualization. We don't get a lot of things out of the box, right? We don't just have a function that says scatter plot from D3. We have to build each of the components that is part of our scatter plot. So that means we need to know what all of those parts are for our scatter plot, right? We can't just get it all out of the box. So our first part here, and today we're going to spend a lot more time in activities, is to just look at a scatter plot and try to identify all of the pieces that we have to make when we're building it with D3. So we're going to build a little checklist as our first activity. And if someone from the team could share the link to the notebook, that'd be great. So same as yesterday, we're going to go to an observable notebook and we're going to fork it so you have your own copy and you can make your own changes if you want to kind of follow along that way. So here, let me move my avatar so it's maybe a little easier to see the notebook and I'm not so much in the way. Here we go. And thank you. There's the link to the notebook. All right, so activity 1, what makes a scatter plot? I have a scatter plot here, a very simple D3 scatter plot. And what we're going to do is we're just going to basically make a checklist of everything we have to make to create this scatter plot. There is the code there, so if you want to kind of like sneak peek and see inside, you can do that if you really, really want to. But let's maybe not look at the code and just look at the actual graphic that we want to create. So I'm going to just create a new text cell here, and we'll call this our scatter plot checklist. I'm trying a little markdown. So for this part, I love if we can get, participation from everyone here of kind of what are all the pieces that we need for our scatter plot. So if you want to just post in the chat, like if we're building a scatter plot, what do we have to make? What are all the components here? What do we see on the page? I can kick things off. We certainly are going to need some of these circles, right? We're going to need to build some circles for our scatter plot. So we're going to have to build circles. That's right, Nicole. We're going to have to build our axes, labels. This one doesn't have a lot of labels, but maybe like the axes text there. A cell that holds the final plot. Yeah, we're going to need like a container, right? We're going to need like some medium in which we actually share this visualization. So we're going to need a container. We can also call this our canvas. Okay, we've got text, right? We have our values, our X and Y values. So we're going to need some data, right? We're going to need data to make this of X and Y values. X and Y coordinates. Yeah, and that's a great point right there about scales. We're going to need some scales, right? So we're going to need some way to convert our data of X and Y values into this actual graphic, right? It's converting those values into pixels because right now we're just looking at pixels basically on the page, right? So we're going to make those conversions there. This is getting pretty good. Let's see here. So we've got the circles, we've got the axes, we've got some labels, we got the container, there's the text, there's the data scales. We're also going to need some styling. That's right, we got color. So color styling for our circles. Okay, so I think this is pretty good. I think this is pretty thorough. If we were going to build all this, I think it's also good to maybe know which parts need data. Which part is there going to need data to inform how this works? I think it's going to be a lot, but maybe not everything, right? So circles, that's certainly going to need data, right? Axes, well, it's a reflection of the data, right? It's showing our scales. It's showing them visually. So that's certainly going to need data. Labels, well, if we add like a custom label, maybe we don't necessarily need data for that. We can just write a label in there. Our container, our canvas, does that need data to build a container or canvas? Probably not, right? We don't need a data for making the canvas. We can just create one. So no data there. Text, well, for our axes text, we're gonna definitely need some data. Data of X and Y values, well, I think that sounds like we definitely need data for that. For the scales, will we need data? I think this one actually could be questionable, right? We could use data to inform our scales. So we could use data, we could look at our data set and see the extent of values, right? So to see that our data goes from 10 to looks like about 40 here. We could also just hard code that in if we know our data set, we know what to expect. Sometimes it's actually better to hard code values than it is to use it off data. I often think about, I do a lot of visualizations of running, and sometimes my watch gives me like a weird reading for my heart rate, and it'll say something like 0, right? Which is fortunately not really possible to have a heart rate of 0 when I'm running. So sometimes I should just hard code those values rather than base it off data because I know what the range is that I expect. And the width and height, the way we transform the data into the number of pixels, that doesn't need data. So questionable here, right? We could hard code it, or we could base it off of a data set. Color and styling, well, it looks like here the color is pretty uniform. We're not basing it off any data set, right? We're just giving a generic, blue color for all of our circles. So it doesn't look like any data is there. So this is a really helpful process, I think, whenever we build a visualization. It's just to go through and kind of look and see, all right, what are all the pieces that we need to build? What are all the components? And what parts do we going to need to use data to influence that component? You might be surprised by one, how many components there are for a complicated visualization. There could be a lot. And also just how many of them don't actually maybe need a data set to drive that component. So it's a very helpful exercise, I think, to go through. All right, so we have this checklist. We're going to use it later as we build our visualization. Onis Fotis mentioned, yes, we might also have tooltips potentially that could use some data as well. I don't know if we'll get to that today, but definitely something we'll highlight in the course. So we have this checklist. We'll use this later. Now let's go back and start talking about a few of these components and how we build them. So the first one I want to highlight, because it's just such an important part of data visualization, is scales. So in D3, a scale is a function that maps an abstract dimension of data to a visual representation. So we're taking that range of values there. We're looking at some sample data set on cars, and I believe it's like miles per gallon is the range on the x-axis. We're taking that range of values of 10 miles per hour, miles per gallon to 40 miles per gallon, and we're going to map it to the number of pixels on the page. So that's going to be 0 to the width, which is I think about 500 pixels. So let's look at some just really simple scales and see how they work. So here I have a linear scale that takes data, and the values are 1, 50, and 100, and it uses to change the radius of the circles. So it's a linear scale, and we can see up here how we declare this in D3. There's many different types of scales in D3. We're going to cover just a couple today. And this is probably the most common one that you'll see, which is scale linear, which means a linear scale. And what these functions take are two parameters. So we've got a domain and a range. And the domain is going to be the data, right? The extent of values for our scale. So for here, we just hard coded it, which is 1 to 100. And then the range will be sort of the output of this scale. So when we input our data set, we input a data value, we're going to output the number of pixels we're going to use for our radius. So here it's 5 to 25. So you can see for the smallest one here, it's going to be a radius of 5. And for the largest one here, it's going to be a radius of 25. So for the middle, it's coming up with a value, right? We didn't have to say what the range would be when the value is 50. A linear scale is going to figure that out for us. It's just going to take the extent of values and it's going to determine, okay, given that 1 means 5 pixels and 100 means 25 pixels, I know that 50 is going to be in the middle, which would be like 12 and a half pixels, right? It's going to interpolate those values for us. So it figures out some logic, it figures out a function for how to determine the number of pixels. So given any value, it's going to then output it for us. So if I give it a value of, say, 200, can anyone guess what the number of pixels would be? Would it work? Would it just break and go 200? It's beyond the extent that you provided. What do you think? 200 pixels, or sorry, 200 for the value I supplied. What would be the output in the range? Perhaps there's a lag or everyone's a little shy today because they don't know. They're not sure. Well, okay, I'll tell you. So if we put 200 in, it will not break. It will give you a result, and the result would be 50. It'll continue that logic. Exactly. Thank you. It'll continue that logic for us and say, given what you've provided for me, I now can take any value and I will try to give you a result. So if I gave it a value of 0, do you think it would still work? Would it be 0 pixels? No, it would actually give us a value that is greater than 0. So I'm not exactly sure what it would be. I guess it'd be like a little bit, maybe a little bit 4.5, something like that. But it would continue to work. Yeah, the linear range, it would calculate it, right? That's exactly right. Yeah, D3 scale linear, it's a function part of the D3 library. If you type in d3.scale, you'll see all the variations for different types of scales. But this is probably, again, one of the most common ones that you're going to see. It's used in many, many data visualizations. Okay, so this is one. Let's look at another one. So this is an ordinal scale. So this scale takes the data and sets colors to it. It maps each point 1 to 1. So here, unlike the linear scale, where I only supplied 2 values in the array for the domain, which was 1 and 100, here I've given it all 3. So 1, 50, and 100. And I've mapped those to specific values. So here are specific colors. Steel blue, a very popular color in D3 examples. You'll see a lot of steel blue. Orange and magenta. So this is different, right, than a linear scale. It's not interpolating values for me. It's basically just looking up values. So if you give it the value of 1, it's going to say, oh, that's steel blue. Give it the value of 50, it's going to give it orange. If I gave it 25, what would happen? Would it work? Work here maybe is a bit loaded. It will return something, but it may not return what you would expect it to return. It's not going to give you some color that's in between steel blue and orange. Actually, for an ordinal scale like this, it'll basically just give it the next value in that array. So if you go to the end and it gives you 25, it'll probably just give you steel blue. I have to test this exactly, but that's usually how it kind of works. So here, it doesn't have logic for figuring out how to handle different types of values. You have to give it a one-to-one mapping of exactly what you want it to do. Now, you could actually make a color scale that is a linear scale. It doesn't have to be ordinal. And then it would try to interpolate values for you. But often you're going to see something like this for a category, right? For a category of values, you're often going to see an ordinal scale. That's very common. So what we're doing here, and this is a concept that we do a lot, and sorry, I'm actually trying to find my speaker notes. Oh, here they are. They got a little hidden. is we're taking data and we're embedding those values into our visualization using scales, right? It's a way we embed data in our visualization, and this is a way that we can learn from our visualization, right? This is what the visualization is trying to do. It's trying to show us these relationships in our data visually so we can understand it better, right? So when we look at that scatter plot, we can understand the relationship between these two metrics better than if we just looked at, a raw table of the data. And there's lots of different ways that we can embed our data into our visualization through different styling. So this is from Semiology of Graphics by Jacques Bertin, describes how we can do this in various methods. So we can do this along the X and Y dimensions of the plane. That's a way we embed data, the position of our elements based on the values in our data set. We can use the size. So say the size of the circle or the size of the rectangle to be being embedding of the data set, the value of it, the texture, the color, the orientation, whether it's at an angle or it's not, or the types of shapes. So maybe we can change, the types of cars. Maybe the number of cylinders for the engine is going to determine the shape of the mark that we, whether it's a circle or a triangle or a rectangle. This is just a few examples. There's lots of different ways we can do this. And this, again, is how we communicate our data. This is how we show it to other people so they can learn something from it. Sometimes you might see using multiple methods at the same time, kind of double encoding. So you might actually have the position and the color to represent the same data point that you're using. This way to kind of emphasize that relationship. So it's a good concept to have in mind because this is really crucial, again, to data visualization. This is what we're doing with data visualization. We're taking data and we're embedding that data through different visual mediums. So let's go to our next activity to start building some of these scales. We're going to start building linear scales and ordinal scales, again, just to kind of get that muscle memory to see how that works. We're going to cover essentially what we just did before, but we're going to start right into code ourselves. So I'm going to go back to our notebook, go to activity 2, and here we've got linear scales. So the prompt here is we want to create a linear scale that takes a value between 0 and 1 and outputs a value between 0 and 100. So this is just, again, for demo purposes or for, teaching purposes. Often we might use this to embed a visual sort of effect to our data set. But here we're just doing it just like, how do we convert 0 to 1 to 0 to 100? So here we'll write a little bit of our D3 code. One thing that's really cool about working in Observable is that if I type D3, I can just, and hit period, I can see all the different functions available to me in D3. Depending if you also use this in a text editor, you'll get this as well. But this can be a great way to just kind of quickly see what's available. And if I start typing in scale, I can actually see all the different scales available to me. And I mentioned before, there's a lot, right? It's not just linear scales and ordinal scales. There's many, many, many types of scales here. So we're going to use a linear scale for now. So we'll do scale linear. The way this works is we call our function, and then we start providing some methods. So one is going to be for the domain, and one will be for the range. So the domain, you can think of that as your input to the scale, right? So that's going to be the extent of values that you use. So for this one, it's going to be 0 to 1. And we're going to put this in an array. So we're going to do 0 to 1 in an array. Here again, we're getting some information about the domain. And then for the range, that'll be the output. We'll give it that extent of 0 to 100. There we go. We've got this function for our linear scale. Now I could just call this at the end here for a value. I could put in the value of 5. And I can see that it outputs 500. That's because 5 is way beyond the extent of domain here. But we know that 1 is 100, so 5 would be 500. So let me go do like 0.5. I think that's what I meant to do. We'll see that gives you a value of 50. In Observable, right, we could actually just name this function something, though. So we can call this my linear scale. Then in a separate JavaScript cell, we can call it that way as well. So we can call it my linear scale. 5 value of 50. Checking to see if there's any questions. Hopefully this is fairly intuitive. This is, kind of, again, one of the simplest scales that you can implement with D3. All right, so why don't we make this a little bit more practical, something you're going to see more often in examples, and base this off of a data set. So instead of hard coding in everything, why don't we try to find the extent of values from this data set and use that for our domain? So here is this popular data set, this iris data set. And you'll see this for lots of data viz examples in many different libraries, not just D3. It's a popular one because it's a nice data set. It's not too large. It's got some interesting trends in there. It's got both, numeric values, and it's also got categorical values. So it can work pretty well. We're going to use one of the metrics here, one of the values, this sepal length, and we're going to use that to create the domain for our scale. So how would we do this? What's like the method? If you could describe it? I mean, you don't know the exact D3 function for it, but if you can describe what would be the method to figuring out those values? I'm noticing that question there. Does scale linear take any parameter itself? I believe, it's not a method that I've used, but I believe you actually could give the domain and range within just the parentheses here when you declare scale linear. It's not that commonly done. I have to double check. I know you can do that for ordinal scales, but I believe you might be able to do that for scale linear as well. Typically, you're going to see it like this, though, where you declare a domain, you declare a range. I guess that's sort of like a shorthand option. Yeah, so that's right, Nicole. We're trying to map those values, right? We're gonna try to retrieve those values, and as Heba says there, we want to find the min and max. So why don't we do each of those steps? So why don't we first just map the values, and then if we can try to retrieve the min and max of them. So I'm going to do iris.map. Oh, did that work there with the scale linear of supplying it in there? Let's see. Let's actually, that's a good question. Why don't we just do that real quick to see if that works? So if we just did the domain, range, and I won't call this my scale. Oh yeah, it's called 1. It does the same thing. Yeah, there you go. Yeah, so that is a shorthand for it. I have seen it with ordinal scales. I haven't seen that frequently with linear scales, so that does work as well. Thanks for highlighting that. Okay, so we're going to take our iris data set, and yeah, let's map the values. So we're going to do a map method. We talked about this a bit yesterday in our lightning fast cover of JavaScript. And so we're going to first, we're going to write a little function here to retrieve that value. So it's going to be using the data. So I'm going to use D here and do d.sepal length. And that will give me all the values in my data set that is the sepal length. And now what we want to do is we want to get the min and max of those values. So here, let's call this my values. And now we want to get the min and max of those. So in D3, we have those functions. Those are D3 functions, D3 min, D3 max. And for that, you're just going to do D3 min, my values. That'll give me the minimum value. And then we could do another D3 max and call my values. Now give me the maximum value. All we got to do is now put those two values into our domain, and then we've got our scale based off data. So we'll call this min value, and we'll call this one max value. Now when we declare our scale, we'll do D3 scale linear. Domain will be now an array of our min value and our max value. Range will be, I think the prompt here says between 0 and 1. There we go. And now if I give this a value of, say, 5, I'm going to return some value between 0 and 1. So we did this in kind of a long form. There's a sort of shorthand for doing this, which one person here has highlighted, which is to use D3 extent. So extent is going to be another function that is like min and max in that it does both of those at the same time. So instead of just giving you one value, it's going to return that array of the extent of values, which will be the min and the max. So I can make a new JavaScript cell, call this extent values. We'll use d3.extent. We'll put in my values. And there you go. You'll see it's the same values as before. So we could use that. And then in our domain, rather than put an array with the min and max, we can just use extent values. Often in D3 examples, you might see all of this all this code put right into the scale itself. So rather than kind of breaking it up into each variable, you'll see all of it when you declare the scale. So here, I'll just show you real quick how that would look. So instead of doing domain is equal to extent values, you might see D3 extent. Within there, we do that map. Right? And this is a method you're going to see very frequently around declaring scales. So typically, you just kind of see it all in one spot. To note, you don't have to use map. So D3 extent takes an optional parameter, which is to tell it how to find the value in your data set. So here, we just supplied it an array of all those values. But D3 extent could also, let's make a copy here, take our original data set, and we could give it the logic for how to find that value. So this is called like an accessor function. So this is a function that's going to try to access the metric or the column that we're looking at. So I'm going to do D here and D.sepal length. See, returns the exact same thing. I would say this again is probably more common way you'll see D3 examples used. So if I go down here, instead of again mapping the values, you're going to see someone use that extent function and use the accessor function for finding the value they're looking at. Okay, linear scales. Let's go into ordinal scales now. So we're going to again do a very simple example. So we're going to do one where we have an ordinal scale that takes the value of apple, outputs red, takes the value orange, and outputs orange, and takes the value of banana and outputs yellow. So we're going to do the same thing as before. We're going to write D3, look up scale, see all the options. If I start typing O, I'll see ordinal scale. And we're going to give it a domain and a range. So our domain here is going to be apple, orange, and banana. And our range, our output, is going to be red, orange, and yellow. So I call this my ordinal scale. And if we now call this and give it the value of apple, you'll see that gives me the value red. Now, it's just giving me text here. If I use this for something, I would then actually see it. I can just make a quick example of that. So if I wrote a little HTML and JavaScript, and we did something like div, and the style, we'll do background color is equal to, we'll use that my ordinal scale, and we do the value of apple. I have to give it some value in here. We would do apple as well. There you go. Now, if we switch this, maybe set orange. Hey, hello. Uh-oh. Well, I made a mistake here, but this is, I think, a good mistake to highlight. So I accidentally gave it a value that was in my range, not in my domain. So I meant to put in banana, but I put in yellow. And the color came out red. Does anyone know why it came out red? As I mentioned before, we're dealing with ordinal scales. It doesn't know how to interpolate values for us. So if you give it a value beyond that one-to-one mapping. Doesn't really know what to do. Doesn't know how to figure out how to handle it. So what it's going to do is, that's right, Aaron, it's supposed to be banana. So what's going to do is it's just going to start looping, right? It's going to go back to the beginning of your range and just give it that value. So it'll give it the value of red. If I gave it the value of blue, to make this even clearer, it now goes orange. So again, it's just going to the next value in that array. So I meant to give it banana. There we go. That's correct. Yeah, that missing value is not defined. So it's just going to go to the next value in the array, which is the beginning, because I had gone to the end already, and then just gives you that value. Question here, is there a shortcut for that D to field array extraction? It's so common. Yeah, I mean, what you might do is you might write a function to do that for you. So you could write a function that does that common extraction for you, excuse me, and then you can just call that whenever you're doing it. So what would that look like? Let's just go back up to the linear example. So we can call our function extract, and that's going to take a value and maybe the data. And that'll return data.map be that value, right? I've just written a function that now extracts that value from the data. So what I could do is I could just call that. I could say extract, we'll do sepal length, and then the iris data. And then actually we're going to need this first argument here. So I'm just giving it the array. There you go. So you can just write your own function for that. There's nothing that comes out of the box for that. I mean, that's kind of the idea of the accessor function within D3 extent, but you can always just write custom JavaScript. Great question. Okay, so we've written a simple ordinal scale. Now let's do one again based on our data. So I'm just going to copy and paste this scale. So here's my, I'll just call it my data ordinal scale, make it very semantic. And again, we're going to now do it. So we're going to not hard code these values. We're going to base it off of our data. So here, when we're dealing with a categorical value, we can't use D3 extent, right? Because D3 extent is using numerical value. It's going to be able to look at those numbers and figure out the min and max. There's not really a min and max concept when it comes to categorical values, right? So what we want to get here is the distinct array of values, right? We want to find the distinct number of species within our data set. So this is there's a few different methods you can do for this. And depending which type of frameworks you like, if you're, again, an experienced developer and you've got, maybe like using Lodash, there's a Lodash method for doing this. We're going to walk through just kind of a simple, questionably simple JavaScript, vanilla JavaScript method for getting a distinct array of values. So like before, what we're going to do, I'm just going to duplicate this cell. We're going to first just map those values. So d.species. And that is not going to give us a distinct array. That's going to just give us all those values, right? So there's many duplicates here. Next, we're going to do is we're going to declare a set. A JavaScript set is an object that lets you store unique values of any type. So we're going to utilize this vanilla JavaScript object for creating a distinct array of values. So we'll say new set. We're going to supply it the array of all the values. Now you'll see it gives us a distinct array. So sorry, this is not an array. This is a distinct, it's a special type of object called a set object. So here you'll see though, just the distinct ones, which is set. I'm not going to try to pronounce it. I feel like I'm going to mess it up. But you can see those are the distinct categories. Now, to make this into an array, which we want to use for our domain, all I'm going to do is say array from set. Let's see, that just converted it now to an array object, which is what our D3 scale ordinal domain expects. So again, questionably simple. There's actually a good amount of logic here just to get that distinct array. But this is something, again, you're going to see fairly frequently in D3 examples. So it's good to understand how this works. So I'm just going to copy and paste this into our domain. And now that I've done that, that error message went away. There's the same number of categories that before and the hard-coded example, so there's only 3. So now if I call my data ordinal scale and I gave it the value of setosa, now see it goes to red. Functions the same way, but now again, instead of hard coding our values, we've based it off our data. This is again going to be a very common way we're going to see these done with D3 examples. D3 scale linear and D3 scale ordinal are some of the most common types of scales we see in D3 examples, because you're going to be able to use it for numeric values and categorical values, which are common types of values you see in data visualizations. All right, scales. That's a big one. It's really good to know scales. So let's get into the next topic here, which is going to be the canvas. So what is the canvas? What am I talking about when I talk about the canvas? Well, let's not confuse it with HTML canvas, which is a whole nother thing that we're not going to talk about in this course. It is something you can use with D3, and it's pretty cool, but it's a little bit more complicated. When we're talking about a canvas here, I'm just generally referring to the medium in which we render our visualization. So does anyone remember what that medium is that we use? We talked about this yesterday. Again, there's that delay there. I bet you all have the answer, and you're just like, there's 100 responses, but I'll just go through it. So SVG, right? SVG is the canvas that we're using here. So let's take a look at our canvas. Here is an SVG. Doesn't it look great? Beautiful. What do you notice about this SVG? Well, the SVG by default is going to be blank, right? There's nothing in it. It's just a white canvas, right? So against a white background, it's pretty hard to notice. All right, so why don't we give this a little border, and then we can start seeing it. So I just added a border to this canvas with a dotted line. So now you can see that's the size of the canvas that we're looking at. So when we're talking about the canvas, right, in some ways you can think of it as a coordinate plane, right? So it's got a width, it's got a height. So as we put points on this, we're putting points on this plane, right? So if we're thinking it as a coordinate plane, there would be an origin, right? There'd be a starting point. So if I just put a circle without giving it any coordinates, just put a circle on this canvas, it would appear somewhere. Where would that appear if we had to guess? You know, and sort of remember in learning the coordinate plane in grade school, right, be kind of in the center, right? Would it be in the center? Any ideas? Actually, not in the center. Our coordinate plane, when it comes to SVG, is going to be in the top left-hand corner. That's right. And why is that? Why would it appear in the top left-hand corner? That's kind of weird, right? When we're building a data visualization, we kind of expect maybe, things to start at the bottom and move up. Well, this has to do with web standards, right? SVG is built for many things, and it's used commonly in the web. And in web standards, things start in the top left-hand corner, right? I can't see there we go. I think it's also inverted, so it looks like the top right-hand. It starts in the top left-hand corner web pages, right? Because when we go to a website, we don't start at the bottom and move our way up. We start at the top and we move our way down, right? So it's built on the same web standards there. So when we're working with visualizations, we have to remember that. We have to remember that it's kind of the opposite of what we would expect, right? When we're going to be interpolating values for our y-axis, we're not starting at the bottom and going up. We're starting from the top and going down, right? Because of that inverted coordinate plane. And that's a term I might use a lot, inverted coordinate plane. Another thing that's good to note when working with our canvas is that we need to create some margins. So you'll notice here when I put that little origin there, you see that circle, you actually only are going to see a quarter of it, right? The other 3/4 is getting cut off because it's starting at the origin, 0, 0, top left-hand corner. And right, that circle is being drawn, but only a portion of it is visible. That's because the rest of it's going off our canvas. So when we're building a scatter plot, we're building our axes, our circles. We don't want things to go off the canvas because if it's off the canvas, we can't see it. So we want to be able to handle that by adding margins to our canvas. So this, again, is going to be something we see in lots of visualization examples where there's additional logic for handling those margins for us. You may never think about this if you use other visualization frameworks because that just comes out of the box, right? It knows that you need some space around the sides. Maybe there's an optional parameter for setting the margins. But for D3, none of that comes out of the box for you. You have to handle it yourself. So we have to declare margins. We have to add them to our visualization. And we'll walk through what that looks like in this next activity. So I'm going to go back to my notebook. And we're going to scroll down to activity 4. And the prompt is here is to create an SVG that has a width of 600 pixels, a height of 400 pixels. So I've got a little bit of code to get us started. It already creates an SVG. This is a function that we use a lot in Observable, just given how we're writing a lot of our code just in JavaScript cells. So rather than having to write some HTML, selecting that and appending an SVG to it, we're just going to create an SVG and return that. This svg.node here, again, you're going to see this in almost all of your Observable examples. When we create an SVG using this method, or we select an SVG, we're not actually returning the value itself. We're returning this D3 selection of it. So if I got rid of the dot node there, you can see, oh, I'm getting this object. This is the SVG. Dot node just means I want to return the actual value. I want to return the actual SVG itself. So just a quick explanation of that. So when we create this SVG, we're going to want to set the width and height. So I'm going to give it an attribute of the width. Talked about setting attributes this way yesterday a bit. So I'm just going to give it the number of pixels. That would be width. Attribute height. Oh, sorry. I'm giving it variable names as if I've declared them already. I have not declared those. So I'll just give it the hard-coded 600. 400. Often you'll declare variables to do this, but for now I'm just going to hard-code those values. Okay, so we've got our SVG of 600 by 400. It looks beautiful, right? Let's maybe give it again a little border. I'll give it style border 1 pixel dotted black. Now we can see it. Okay, so now we want to add margins to this. And what we're going to do to add margins is we're going to increase the width and height of our SVG. So this actually is where it's nice to set variables. So we'll call width equal to 600, call height equal to 400. We'll use those now rather than hard coding them. So now to add those margins, I'm going to increase the width and height by those margin values. And then I'm going to create a container that is then transposed by those margin values. So let's create a new object called margin. Do top is equal to 20, bottom equal to 20, left equal to 20. That question is node observable specific? No, it is not. It is something that you can use outside of Observable. It's often used outside of Observable for various D3 visualizations. Okay, so I've now created an object called margin where it's got a bunch of values, one called top, bottom, left, and right. So what I'm going to do is I'm going to increase my width by that margin left and margin right. And then for my height, I'm going to increase it by margin top, margin bottom. Now you'll see if I rerun this, it gets a little bigger. And now what I want to do is I want to create a container within my SVG that is going to handle for the margins. So this way, I don't ever have to think about it again. I could just now add everything to that container. So this way, my margins are kind of handled for. So I'm going to call this container G. So G is referring to the G tag. It's a tag used in SVG. You can think of it like a div tag in HTML. It's basically just a container. And you're going to see it often used for grouping elements together. So it's kind of easier to see groups, essentially. And you can also see it for margins like this. So I'm going to do SVG and G. And now we're going to handle the margins. So the way you can think about this, and if you ever studied music, there's this concept of transposing something, right? So you take it from one key, you move it to another key, right? So you might move it up, one full step to make it a little bit higher of a pitch, right? So a similar concept here as we're transposing values. We're going to take, our container and just nudge it. We're going to nudge it in the direction we want to handle for these margins. So we're going to call this attribute transform. It's the transformation to do this movement here, and it's going to be called translate. And here inside this value, we're going to tell it the margins that we're going to use. So here I'm just going to add my variables. So do margin left and margin top. The way this works is when we're shifting everything over, we're going to shift it by the X and Y value. So here, since we're starting the top left-hand corner, we're going to move it down, and then we're going to move it to the left. Or I guess, sorry, since it's X and Y, we're first going to move it to the left, and then we're going to move it down. So this translate here, it's going to take an X and Y value, which is going to then handle our margins. So I run this. You can't see anything because it's just an empty container. Let's add a rectangle to this so we can actually see that. So we're going to do G, append a rectangle, an SVG. It's just rect, it's not rectangle. And then we're going to give it some values. So I'll give it width, and that'll be equal to our width variable. Attribute height equal to our height variable. You can see now that rectangle is not along the edge, right? It's within that container that's been moved over by our margin left and margin top. If I appended this to the SVG and not the G tag that's been moved over, you'll see it now goes in the top left-hand corner, starts at the origin, but it ends down here, and that difference is going to be those margins, right? So I move this back to the G tag. It's now back in the center, and now if I increase the margin left, if I increase the margin right, so this little bit of code here, for many visualizations, you're going to see that. You're going to see them declare the SVG, supply the width and height, they increase the width and height by those margins, and then they're going to create a container to handle for those margins. And once you've done that, you don't have to kind of think about margins anymore, right? Now you can just act like everything is about the width and height and not to think about the margins again. All right, so I'm noticing time. So let's get to this next section. This is a big section. And the last part of actually putting this all together is fairly quick when we've gone through all these different components. So we have created our scales. We've talked about margins. Another part about building our scatter plot is actually building all the circles. So that method for creating all the circles based on our data is what we call the data join. And I would say this is probably one of the most confusing parts about learning D3, because it's when you see it, it looks maybe a little counterintuitive, right? And this again is about how we create symbols, if that's circles, rectangles, lines, based on the number of data points. So I'm going to show you this Venn diagram, and it's a good concept to have in mind. And we're going to go through it in more depth on Thursday when we talk about the general update pattern. But it's this method in D3 for how we create elements, so create circles or rectangles based on our data. So the way we're doing here is we have two circles. One represents our data and one represents the elements. And there's three situations we're handling with D3. Today we're going to talk about just one of those. So there's an enter, an update, and an exit. And what this Venn diagram is showing is that when you've got a situation where you have data but no existing elements, there's no circles already, we're going to enter. We're going to create new circles. When there's a situation where we've got existing elements and data that match, there's a circle for every data point already. That's called an update, where we're going to update those circles. Lastly, if we've got a situation where there's no data but existing elements, we want to exit those circles. We might want to remove those circles. So that's the last one. That's the exit pattern. Today, we're going to be talking exclusively about the enter method. Since typically when you're creating a new data visualization, you don't have anything on the page yet. You're making it for the first time. You're going to want to enter those values based on our data. So if we think about this, right, we've got a data set, and then there's this second part called existing elements. So how do we know if there's existing elements, right? How do we get that information? Because we have to evaluate it, right? We've got to determine whether we're in an enter, whether there's data and no elements. So this, again, I think is good to highlight as the confusing part for D3. We start off to figure out whether we need to enter elements by first looking for those elements. Then we're going to compare it to our data and evaluate how to handle it. So here's an example of what that looks like. So we've got that G container. We create a new G container just to kind of contain all of our circles. Not actually necessary, but just kind of common practice. And then we're going to first look for all the circles that we want. So we do a select all circles. So that's what we talked about yesterday, the select all, the way to find everything on the page that matches that logic. Here it's just for a circle tag. We're then going to compare it to our data, which is here just this cars data set. And then we're going to handle it. So we're going to then use join, which is going to figure out for us whether it should be an enter, an update, or an exit. Here, given that we know there's no circles array on the page, it's going to be an enter. And then we tell it, how to style those circles, where to position them, what the radius should be, and all of that. The reason why this is confusing for so many people is that you write this select all first. And it's kind of an odd thing to first search for something before you have it. You might think the method would be like, all right, for each data point, create a circle. And here instead, we're saying, first look for all the circles. I know they don't exist. Now here's the data set. Now merge the two. And the reason why this can be really nice and why we do it in D3 is that there's lots of situations where it may not be so clear if there's a circle on the page. Say you've got a scatter plot and you want it to transition. You want to move the circles around because you're updating the data set. Well, then you might want to handle that, right? You want to look for circles first and then say, okay, I've got 5, but I now need 10, so I just need to make 5 more. Or maybe the opposite, right? When you already have 10 and now your new data set has 5, you have to remove 5. Join here is going to figure that out for us, but we have to help it by telling it what elements are on the page and what our data set looks like. Okay. So just actually walk through all this. The first, the select all, the data, and the join. Just good to note too, for older versions of D3, you'd actually had to specify if you're going to do an enter or an exit or an update. There wasn't a join function that was added in a later version of D3. So some older versions, you might just see it written this way, where they specifically say, all right, I want to enter and append a circle. So I know it's an enter situation, so add a circle for me. Okay. Now let's get into our first scatter plot. We're going to basically combine all the things we've done today into one section. So I'm going to go to the top of the page. I'm going to grab our checklist. I'm going to go to the bottom. Whoop, too far. I'm going to add our checklist. So now we're going to take all those things and add it together for our visualization. So I'm going to go back above and grab a few other sections. So I'm going to grab maybe first our margin convention, all of this here. So I'm going to take that, stick this in here. There we go. Maybe I will make that rectangle that dark. Maybe I'll make it a little bit lighter so it's easier to see our circles on top. Style fill that to light gray. That's the hex code for light gray. There we go. Now we're going to take maybe some of our scales. So I'll take this linear scale up here, This will be for one of our axes. We actually haven't said which metrics we're going to use, so we'll call this our X scale. We do another one for our Y scale. And maybe, let me just take a look at the data set again. So we had sepal length. Let's do sepal width for our Y scale rather than sepal length. And then we're going to take our ordinal scale. We can use those colors as well and map that. So I'm going to take my data ordinal scale. And let's maybe just call this color scale. Well, I'm just noticing some questions here. Does enter and update still make sense if we want to style elements differently? We're going to cover that in a lot more depth on Thursday when we talk about how to basically handle for all these different situations. Because, yeah, sometimes you want to style things differently, so you might want to update them first. You know, you also have to think about whether if you're changing a data set, if it makes sense to reuse the same circles, right? You might want that to mean something. So if a circle represents maybe the state of New York, and you've now updated the data set with the state of California, maybe you don't want that circle to transition and animate because it's a different thing, right? It's representing something else. So we'll talk about those situations on Thursday and how to handle that. Oh, and this one question here, is there a reasonable case where the select all selector and the join selector are not the same ones? Absolutely. So what you might see is that in the select all, you might be looking up a specific class. So like say there's many types of circles on the page, but we're looking for just a class of circles. So you might see that it's searching for that class, but then in the join, it's just saying, I want to create a circle. And then afterwards, you would specify the class you want to add. So you will see those sort of situations. And we'll get to that in this course for sure. Okay, so we've added our scales. We've added our color scale. We've added our X and Y scale. And now we're going to do that little data join we did before. So we're going to say G, and we can append another G tag just to group all of our circles together. We're going to start off this data join with, again, searching for the elements on the page that don't exist. So we're going to do select all circle. Oh, that extract function, yeah, that's just basically mapping the values. You know, maybe for here, given that it's a little bit more complicated, let me just do this in the simple way. That's kind of the default way. So we're going to do, and I'll create this. There we go. This is the more standard way. This was simple. I just got to put the E there. There we go. That's the more common way. All right, so as I was saying, we're doing our data join. So first we're selecting all the circles, then we're gonna that don't exist, and then we're gonna put it in our data, so that'll be the iris data. Then we're going to handle that by doing .join circle. Now we start just supplying it some values. So we have to give it a radius, so I'll just hard code that as maybe 3 pixels for now. We have to give it some positions. For circles, positions will be a CX and CY. So we're gonna base this off our data, right? We're going to use the data here and our scale. So we're going to say X scale, and now we're going to give it the value for this specific data point. So that'll be d.sepal length. And then for our Y, we're going to do the sepal width. And lastly, we're going to style this with our fill. That'll be, again, based on the data. We'll use our color scale. That'll be d.species. Looks like I have some error here. X is not a function. Oh, because that example is actually calling the value. There we go. And our rectangle is still there. I thought I changed the color of that. Let me just remove that rectangle for now. It looks like, oh, we also didn't give it the right range. Okay, sorry about that. So it's 0 to width. And for Y, this is going to be handled at an inverted coordinate plane. Instead of 0 to height, it's height to 0, right? Because it's going from top to bottom. And there we go. We've now rendered all the circles on this page. You'll notice, though, we haven't actually declared our axes components. So I know we're at time right now, so we probably need to hop. I will supply the example for that. We can talk about that a little bit more tomorrow when we go over line charts and bar charts about axes. But we actually, again, nothing comes out of the box, right? Even though we've got scales for X and Y, we don't have the axes. So we have to create those as well. So we've got most of the way there. We've got one more part we have to add in for the axes, but we'll get to that tomorrow. So lots of topics today. Hopefully you guys all found that helpful. And yes, so in the notebook here, we've got the actual slides at the top of the notebook. So if you want to access those, you can do that. You can always watch this recording as well to see everything. And I didn't do this yesterday, but I'll make sure to do it today. I'll merge these changes that I did today into the original copy. So this way you can see everything and have a copy for yourself. So thank you all so much. I really hope you enjoyed this today. And I'm really excited to go again tomorrow into more depth on line charts and bar charts. So thanks, everyone. See you tomorrow.